Hello, everyone. My name is Jocelyn Burtch, and I will be presenting my literature-based research project on the effect of cleaning agents on presumptive blood tests and DNA analysis of bloodstains. Blood is one of the most common types of physical evidence found at crime scenes involving physical violence. Once a bloodstain has been located, DNA can be retrieved from the blood and be used to connect perpetrators to a crime. Being able to identify who was at a crime scene can provide valuable information needed to solve crimes. There can be times, however, when bloodstains are hard to see or look similar to other types of stains. In order to detect the presence of blood, crime scene investigators will often use a presumptive blood test. These tests are rapid and simple to use, and many of them are based on an oxidation reaction. Hemoglobin in blood will act as a catalyst with the test and produce a fluorescence or a color change. Here we have an example here at the top of this picture of an unseen bloodstain. And the picture on the bottom is the same bloodstain after a presumptive test was applied. But now we can visually see the stain and know that there was once blood present here. The most commonly used presumptive blood tests are luminol, Blue Star, and Kastle-Meyer. To give a little more background on the three most commonly used presumptive blood tests, luminol is a powder that is mixed with hydrogen peroxide and a base. After luminol is sprayed onto a bloodstain, it is oxidized by hydrogen peroxide and is catalyzed by hemoglobin, which will form an unstable intermediate. As the luminol returns to a lower energy state, a blue-violet or blue-green light is emitted. This light is called chemoluminescence and can be seen in a completely dark room. Blue Star is based off the chemical formula of luminol and is also mixed with hydrogen peroxide and a base. Blue Star will go through the same oxidation reaction as the one pictured in the previous slide to produce a blue chemoluminescence as seen in the picture on the right. Compared to luminol, Blue Star has a higher sensitivity and the chemoluminescence is brighter and will last longer. Kastle-Meyer works by applying ethanol, hydrogen peroxide, and phenolphthalein to a sample of blood. The hydrogen peroxide will oxidize the colorless phenolphthalein into phenolphthalein, which will appear as the color pink. Hemoglobin catalyzes this reaction. Unlike luminol and Blue Star, Kastle-Meyer cannot be applied directly to a bloodstain. It must be applied to a swab of blood. There are often times bloodstains from a crime scene are washed with household cleaners. Perpetrators will do this in an attempt to destroy evidence connecting them to the crime. Household cleaners not only have the potential to visually remove bloodstains, but they can also damage DNA. Sodium hypochlorite and sodium percarbonate are two common ingredients that are found in household cleaners, such as those pictured on the right. Sodium hypochlorite is typically found in bleach, while sodium percarbonate is found in stain removers and laundry detergents. The objective of this review was to examine the effects household cleaners have on presumptive blood tests and DNA analysis. This review primarily focused on cleaners containing sodium hypochlorite and sodium percarbonate, as well as luminol, Blue Star, and Kastle-Meyer presumptive blood tests. I selected journal articles for this review by dividing the project into two main concepts: presumptive blood tests and DNA analysis. I accessed Google Scholar and PubMed database and refined my search using bloodstains, cleaning agents, sodium hypochlorite, and sodium percarbonate as keywords for the first concept, and bloodstains, DNA analysis, and PCR for the second concept. From there, I selected journal articles for the first concept if they included washing bloodstains with a household cleaner and testing the washed bloodstains with a presumptive blood test. Journal articles selected for the second concept had to include extracting DNA from a bloodstain washed with a household cleaner and determining DNA quantity and quality using gel electrophoresis and/or PCR. When it came to the presumptive blood test, sodium hypochlorite and sodium percarbonate diminished the color of luminol, Blue Star, and Kastle-Meyer. Using Kastle-Meyer as an example, when applied to a washed bloodstain, a faint pink color may appear rather than the dark pink color that is normally associated with a reaction to blood. Bloodstains washed with sodium percarbonate were not always detected by all three presumptive blood tests, with Kastle-Meyer being the most sensitive to its effects. These false negatives still occurred even when the bloodstain could still be visually seen. Applying presumptive blood tests to sodium hypochlorite without any blood can create a color change and produce false positives. False positives using luminol or blue star can have the same chemoluminescence intensity as hemoglobin. Here we have an example of blue star that was applied to carpet and ceramic tile. In the top left-hand corner, each of these surfaces was washed with a bleach containing sodium hypochlorite. And even though blood was not present, blue star still produced a chemoluminescence. The top right-hand corner of each of these surfaces had blood that was unwashed. The bottom left-hand corner has blood that was wiped once with the bleach, and the bottom right-hand corner is blood that was fully washed with the bleach. And as we can see on the ceramic tile, the blood that was fully washed had a diminished chemoluminescence intensity compared to the blood that was not washed. And porous surfaces, such as carpet, were not as affected by the cleaners as non-porous surfaces. When it came to how cleaning products affected DNA analysis, there was significantly less DNA extracted from washed bloodstains compared to unwashed bloodstains. There was also significantly less DNA extracted from bloodstains washed with sodium percarbonate than sodium hypochlorite, as is seen in these two graphs. These graphs also compare the amount of DNA extracted from cotton and silk fabrics. And as we can see, there was significantly more DNA extracted from the cotton, more porous fabric than the silk fabrics. The quality of DNA was examined using gel electrophoresis, and it was shown that sodium hypochlorite and sodium percarbonate produce some DNA degradation. Here in this picture, we can see the intact DNA bands of unwashed bloodstains, and in this gel, we can see the sheared DNA bands of bloodstains washed with bleach. It is important to understand how cleaning products work in order to understand the results that we're seeing. Sodium hypochlorite reacts with the hydrogen peroxide found in presumptive blood tests and will produce a positive result, just as hemoglobin would. When blood is washed with sodium percarbonate, the catalase enzyme in blood will convert the sodium percarbonate into hydrogen peroxide and will break down the blood. This produces the little to no color change seen in presumptive blood tests due to the lack of hemoglobin present. Understanding the results of a presumptive blood test relies on visually examining the color change that is produced by the test. When bloodstains are washed with cleaning products, diminished or absence of a color change can result in misinterpreting if blood is present or not. If a bloodstain is determined to be negative, valuable DNA could be lost. Fortunately, the quick, bright chemoluminescence form from sodium hypochlorite can be distinguished from the gradual chemoluminescence form from hemoglobin. Crime scene investigators should take into consideration that bloodstains could have been washed with a household cleaner and should understand how they interfere with presumptive blood tests and DNA analysis. Understanding the effects of washing bloodstains with household cleaners could be further explored in additional studies that could include using different cleaning products and/or presumptive blood tests than the ones used in this review. It could also compare the effects of washing the bloodstains with different washing techniques. For example, hand washing versus machine washing. Bloodstains could be placed on different surfaces and comparing the effects of different concentrations of cleaning products. I would like to thank Professor Southwell for advising me through this project and to Dr. Johnson for helping me choose my topic of research. Thank you.